Hey, good morning all. Today I'm just creating a small video for discussing a singleton pattern. This is basically a technical topic, and I think anybody who has done development I'm sure knows about what a singleton pattern is. I think I would like to make it a little bit more interesting than the usual stuff. So yeah, let's quickly dive into that. The first thing is, what is actually a singleton pattern? So in singleton pattern, basically a class is designated to have only a single instance ever. So during application lifetime, always the singleton class will have a singleton instance or a single instance, as the name suggests. So where do we use that? So we use that basically for the instances where we have where the cost of creating an object is an expensive operation. So in that such cases we use it. For example, the file system, shared networks, or trying to write some heavy logs or something like that. So that's about it. Now let's get into what is a feature of that, or let's first discuss how the structure wise how it looks. So in structure wise, you have a class. Basically, you mostly define that into a sealed class, though that is not, I would say, really mandatory, but it's for the JIT compiler optimization. It is recommended to declare that as a sealed class. Then that will also make sure that nobody will be able to inherit that. Then comes the constructor part. So in constructor part, we'll have a private constructor to make sure that nobody is able to instantiate that class from outside. Then comes the instance part. So in the instance part, you'll have a public property which will give access to the instance of this particular class. Getting to the next topic, the feature of course is, as I mentioned, during the lifetime it will either have 0 or 1 instances. Then we do not pass any parameters into the constructor, so we don't want somebody to sort of change the behavior or things like that. So it's recommended not to have any parameters for such classes, for a singleton class. Also, it is recommended to have a lazy initialization for the instantiation of the object, and the reason being that, as I mentioned, we are going to mostly use that in scenarios where we need to do some heavy lifting while creating the instance of an object. So that's why you should also consider having the lazy initialization. Right, so moving on, the implementation approaches, I'm going to quickly discuss that. I think for that I'll quickly switch to the Visual Studio. I have already written some code here, as you can see, and I think I just wrote it some time back, so you can have a quick look here. As I mentioned, we'll start first with the naive implementation, where we, as I mentioned, will have a seed class. This is the class. Then I have created a private variable here which I'm going to use in the property. There's a private constructor, and here I have simply mentioned that if the singleton instance is null, give a new one, otherwise give the same instance. So this is like the same instance, but the problem with this is that if in a multi-threaded environment where there are concurrent users, you may end up into a situation where two users are able to get into this thing, and then you will have still multiple instances. Probably you can make a small program to verify that, try to trigger try to access from two different users in the application. You will be able to see that you can create let's say two instances, though you are intending to create only one instance. So if we improve the implementation, so what we have done here is that we have just now created a new, it is basically the same instance which we had. Then we have a static read only lock object which I have created here. Now why we have created static and read only is because we are going to use it into a static property, so it has to be a static variable, and read only because we are not going to change it or something like that. So we simply put a lock, we check if it is instance is null and return the new instance, otherwise return the existing instance. So lock object, make sure that at one point of time only one person will be able to access it. So this is one thing which we can do. Then backdoor lock. So in the same approach which we have used in the naive locking, we were first applying the lock and then we were checking for null. But the better approach from performance point of view would be to first check for null. Otherwise, too many people will try to access the lock. But we first check if the instance is null, and then whoever user finds that instance is null and hits fist will get an access, will create this lock and will return the instance of or rather create an instance of our singleton class. So performance wise this should be a little bit better. The final approach which I would like to discuss here is the lazy approach, rather the lazy initialization approach, which is provided by the .NET framework itself. It is part of a system namespace, so system.lazy. And the advantage of having using this lazy initialization, so the first advantage I will say is that it already manage the thread safety for you. You don't have to create all those objects and put the locks and things like that. The second advantage is that it automatically handles the null, so you just simply have to write instant.value and all the null handling you can sort of skip. It will only return when it is null. So this will also be one of the advantage of using the lazy class. And the third advantage is that you have a much more cleaner and smaller code. As you can see here, if you compare it to your batter locked code or things like that, you have written, let's say, how many lines? I'll say about you have 13 lines of code, but in your lazy locking you can see the same thing you were able to achieve with less number of lines of code, and it's much cleaner in the sense. So as you can see, I've just created a static read-only lazy private instance, and in the constructor I've already passed that. I have initialized the singleton class here, so you can see that this particular singleton lazy t takes a func as an argument, and here I have initialized the class. And in the property itself I just have to pass instance.value and the return type of will be singleton lazy. So yeah, this is about the singleton implementation. Now let's jump back to the block which I have. The next thing which I want to talk about is that most of the people consider this singleton pattern as an anti-pattern, and the reason for that is basically it's very difficult to test. So while writing the unit test, it is difficult to test because the share state we are using because of the share state we are using the static keywords there. Then it does not follow the separation of concerns because yeah, and also the don't repeat do not repeat yourself principle is also which you sort of break. The next topic is about you can use also the singleton classes as well, rather the static classes in place of singleton, and what will be the differences. I think I would like to talk about some of the important topics here. First is that the singleton doesn't support the polymorphism, while the static class it supports the polymorphism, but of course the static class does not support the polymorphism. And then It can be serialized. Of course, the singleton classes can be serialized like a normal class, but static class you cannot do that. And you can implement the interfaces for the singleton class, but not with the static class. Now moving on, there are other ways of creating the singleton object. I think you might already know about the dependency injection and the containers. So through the container frameworks, there are different container frameworks available, which are like Unity and mock, and there are some mocking also which you can do with those frameworks. So it's about creating or rather initialization of the object. So in that we have in .NET Core we already have something called service collection. Through this service collection we have an inbuilt this container is available as part of the .NET Core framework. So there you can simply rather initialize the variable, for example I order service, and you can say order service, so you have sort of already mapped it, and then you can also say that I want to create always a singleton type of an object. So through the use of such container frameworks as well, you can create a singleton object. So yeah, that's all I guess for this video. I hope you like it. Thank you. Bye bye.